In this video, we're going to do another practice problem with a scenario. So we have a runner who wants to test the effect of volume of music on her speed during a 50-meter run. She completes the 50-meter run at 3 different volumes, 1, 2, and 3, with 3 being the highest. For each volume, she does 3 trials. At volume 1, she finishes the 50-meter run in 11 seconds during trial 1, 10 during trial 2, and 14 during trial 3. At volume 2, she finishes 50-meter run in 9 during trial 1, 8 during trial 2, 10 during trial 3. And at volume 3, she finishes the 50-meter run in 12 seconds during trial 1, 13 during trial 2, and 9 seconds during trial 3. For this scenario, complete the task below. Let's find our variables. So the runner is changing something in this experiment. They want to see if the volume, different volumes, will affect the speed of the run, or how fast the run is being completed. So different volumes would be our independent variable because that's what the scientist or the runner is actually changing herself. And then the dependent variable is speed of run. Oops. That's an N. Speed of run. Or you could say time to complete a run, right? Depending on how you view it, it's the same idea. What are some control variables? Well, there's many you could have thought of here. You could have thought of the type of music. You could have thought of maybe the type of shoes the runner was wearing. Maybe the type of terrain, maybe how tired the runner was already. Maybe the diet of the runner. So a whole bunch of different variables need to be kept the same. I only asked you for 2, but make sure you come up with some specific ones that could have affected the time to complete the race, and those must be kept the same. So now the difference here is we're going to try to make an observation table, but with derived quantities. Now, this observation table, the title will be the same that we normally see. So we'll call this our third observation table in this lesson. So table 3.0, the effect of music volume on, we can say, running speed. Okay, so that would be our title, and now you would underline it with a ruler. It's hard to use a ruler on the computer here. And we're going to base the table off of this table here. So we're going to have our column 1 will be our independent variable. So that'll be the volume of music. And that's in units of 1, 2, or 3, with 3 being the highest. And then we're going to have our dependent variable. So we have our independent variable here. And then we're going to have our dependent variable here, which is going to be the run time, or time to complete, well, let's call it run time, in seconds. And then over here we're going to have our derived quantity, which is going to be our average run time in seconds. And so we basically had 3 volumes. We had volumes 1, 2, and 3, with 3 being the loudest, and we had 3 trials. And I should have made a bit of space here. Let's do run time in seconds And we'll do this trial 1, trial 2, and trial 3. So, for the volume 1, we had 10 seconds, we had 11 seconds, 10 seconds, and 14 seconds. So 11 seconds, and then if you can see here, so it was 11 seconds, 10 seconds, 14 seconds. For trial 2, or for volume 2, the trials were 9, 8, and 10. 9, 8, and 10. And for trial 3, I shouldn't say trial 3 because that's not trial 3, it's volume 3. Trial 1 was 12 seconds, trial 2 was 13, and then 9 for trial 3. So we have 12, 13, and 9. And we're going to have to figure out the average run time. So remember, the average is just you take a look for volume 1, the average run time, you'd add the trials together. So you can have a calculator, you can do it in your head if you'd like. But you'd have basically your 11 plus 10 plus 14. You divide that by 3 because there's 3 trials. So you get about, and I'm going to leave 2 decimal places, 11.67 seconds. For your volume 2, you had 3 trials, 9 plus 8 plus 10. That's 27 divided by 3 trials, about 9 seconds. And for your volume 3, you had 3 trials, 12 plus 13 plus 9, divided by 3, about 11.33 seconds. So notice that the volume 3, the loudest, was 11.33 seconds to complete the race. Volume 1, the lowest, was 11.67 seconds to complete the race. And volume 2 was 9 seconds to complete the race. So based on our average run time, based on the derived quantity, which volume allowed the runner to complete the race the fastest? Explain how you know. Well, it looks like it was volume 2. And that's because the average run time was the lowest. 9 seconds compared to the other ones being higher. And so if you take a look at volume 2, over here, if you only compared one of the trials, let's say trial 3, you might think that volume 3 was the best in this situation. But, and that's because you compare it to trial 3, volume 2 had 10, volume 1 had 14. You would think that volume 3 is the best because it had the lowest number. So that's why it's important to look at the average instead before you make a conclusion. Because sometimes a trial could have been a fluke. Maybe during trial 3 of volume 2, 3, and 1, maybe during volume 2, the runner tripped or was wearing different shoes or there was too much wind. So there might have been a fluke. So that's why it's important to take averages of your trials before you make an actual conclusion. So in this situation here, it turns out that volume 2 was the best volume to listen for the runner to listen to in order to complete the race as quickly as possible. So in this video, we saw how to identify variables, dependent, independent, control variables. We saw how to make a table considering trials, and we saw how to calculate averages and the importance of calculating averages and using multiple trials when doing an experiment.